Please welcome from Manutelligence, Maurizio Petrucciani. Warm round of applause, please.
Hello. Hello, everybody. So thanks to be here and to let me have the occasion to talk about this project. This is an European project that is funded by the European Commission. It's part of the Horizon 2020 program. The name of this project is Manutelligence, that is meaning mostly the fact that we would like to provide solution for the manufacturing, for the design, by supplying a platform that is able to support and make available to different kind of industrial cases a unique platform able to support their processes. This project is composed by a consortium of 12 companies. The first group of 4 are industrial companies. So there are some well-known companies like Ferrari, or like Meyer Turku, that is the shipbuilding company, or a company like Lindbäcks, that is a construction company based in Sweden, specialized in prefabricated wooden houses. And the Fab Lab, that is in practice the Fundación SIM laboratory for the 3D printing. Then there are other 4 partners that are providing the elements, the software elements to build this solution. You can see there is the Dessault Systèmes company, the company that I'm working for. This is providing the PLM part of the software and also the CAD one. There is the Holonics company that is providing the IoT solution. This is a spin-off of a Polytechnic of Milano. Then we have Balance. Balance is a consulting company based in Bremen, in Germany, that is working on LCC, that is a life cycle costing computation. And then there is the SUPSI, that is the University of Switzerland, based in Lugano, that is providing the solution for the LCA, that is the life cycle assessment in terms of calculation for the environmental impact. Then the last group of partner is the one that provides, that we say, the part of academic and theoretical support to all the solution being built. So we have BIBA, that is a research center from Germany. We have VTT, is a research center from Finland. We have Rina Consulting, that is a consulting company based in Italy, and then the Polytechnic of Milano. Where we started from this project, starting from some consideration about the current status of the manufacturing, which is the evolution. In the past 50 years, the most important thing was to increase the production and with the huge manpower contribution. Now the trend is totally the opposite. Increasing production with less manpower. This implies that the companies have to change either to be competitive, either to, let me say, let the European nation be able to provide jobs and labor. So changing in this direction means to be more attractive and more capable to introduce the new technologies. And other factor very important is the services. That can be a new factor of business. In fact, the companies that are the most attractive and the company that are providing the best results in terms of revenues are the companies that are improving their digitization and the transformation. The companies that are doing that, they are improving a lot their revenues. So what is needed? It needed to be very agile. It's needed to be able to manage the complexity by leveraging on IoT technology, leveraging on the cloud to reduce the cost of infrastructure, especially for hardware, and to be able to be competitive in the market by adopting the new technology for the manufacturing. So again, when we start, we say, but which are the challenges, which are the problems that we would like to treat and to try to address in some way? First of all, the capability to provide a solution that is able to supply a collaboration solution. Capability to provide a solution that is able to enable the company to manufacture products that are tailored for the specific end user. Nobody would like to have the same product as his friend. So, other point was to be able to be very quick and able to deliver on time on the market, to be competitive and to arrive, let me say, first. Other point was about the capability to produce everywhere without make an equilibrium between what is the local and the global production. And last, but it was really not least, is the capability to transform the business model from the product business model to the product service business model. That means to be able to sell not only the product, but to sell the services and design the solution since the beginning, thinking to what can be the business about the services. As you can see in the slide, there is a very interesting case of the heater, where currently the typical option is to sell the burner, and then there is the person that makes the maintenance, and the end user has to pay both. So the possible new development in terms of service business is to sell directly the heat, so that the end user it will be really happy, because you have to not take care about maintenance, about buying and putting a lot of money, invest a lot of money on the system, but just having to pay some amount of money for the heat that he is buying. So in this context, we started to think about what we have to do with Manutelligence, which are the main objectives. One is to develop the methodologies, because without methodologies, we cannot enable the factories, the companies, to use our product. Second, to develop the platform, that is the software platform that is able to support the methodologies. Then, adopting the simulation in order to reduce the aspect of the physical test and to reduce cost. Last, also, to have tools that enable the capability to make cost analysis and environment impact analysis at the beginning of the product development. Because this means that we are able to determine upfront which is the best solution, which is the best material, and which is the material that are the less impact on the environment. So, based on that points, we work with our industrial partner to identify the business case that should be adopted in order to demonstrate the capability of the platform to satisfy the requirement that we said before. So first case is about automotive, Ferrari. So how to use the user experience to improve the car design. The other one is about the construction. How to develop a solution that is able to support the idea to make and build houses for students that are intelligent, that all of the student and the tenant to have the best results in terms of cost of maintenance of the house. Third case is about shipbuilding environment, and especially to think about the vessel of the future, how we can improve the process of designing new ships by taking into account since the beginning of what can be the desired environment from the end user, that is the passengers. And then the case of the Fab Lab manufacturing, and this is aimed mostly to develop a complete cycle from the idea up to the manufacturing, leveraging on 3D printing technology, to enable a community of people, like in Catalonia area, to develop ideas and to be innovative, giving this tool to everybody, not just to a company or people that can have such kind of tools. So first cases, industrial cases that we analyzed. The first one is about Fab Lab, as I said. So full cycle, from the idea, design, up to the manufacturing. The case is the case of the robotic arm Movio that is exposed over there. You can see it live. So in this video, you can see which is the full process that can be done with the platform that we implemented. So you can see that we started from the idea, the development and improvement of CAD design. This CAD design then can be used and can be put in a collaborative environment that is available to everyone in the community. Then everyone can access to the community and access to this CAD design, can derive the bill of material that is the basis then to launch the process of the 3D printing. This is clearly embedded in the platform, and this is the value, I mean, because piece by piece, we already have the capability to design, we have the capability to create a bill of material, we have the capability to print. But in a unique environment, open, in an easy way to a large public, this is something that was not available. So, in this case, you can see that at the end of the cycle, we can have the file, the G-code, so-called G-code file, that is the one that you put in an SD card, and then you will put in the 3D printer in order to make the product being built with additive manufacturing technology. On the same time, we added also a capability to control the energy consumption so that we also can monitor the consumption of energy that is caused by the building of this component. On the side of the life cycle assessment, we added also capability to calculate the impact on the environment, calculating the different parameters like the global warming, like the acidification, etc., directly embedding the tool to make this calculation into the platform, so that you can see that there is a capability of the person in charge to make the calculation, to make his own calculation, and then making these values available to the community in a collaborative environment, so that everyone can consult and everyone can decide which is the best solution in terms of environment impact, clearly. This is something that you can see here is available in a collaborative environment. So we made another kind of analysis. We said, but if I have a lot of different calculations and different possible solutions for a product, how can I select the best one? I need a tool to make, let me say, comparison that allows me to select the one that for me is the best. Then there is another kind of analysis that we put in place that is able to provide a solution, automatic solution, to select the parameters that are for me the most important, to select which are the ones that I would like to maximize, minimize, what is my objective, and then let the system, the platform, make the calculation so that I can then analyze the result, and then I'm driven by the system to select the one. You can see there is the spider chart that is a typical common tool where you can see all the parameters of the environmental impact, and there are the values calculated so that you have a very, very, very easy tool to make your final decision and select which is the product, the version of the product that you would like to use and to print. Automotive case. This is clearly totally different. In this case, we adopted a scenario where we were introducing two different parallel studies. One is the physical study, that is the one to grab all the information coming from a real test. In this case, we did a test in Fiorano circuit with a special car, the FXXK car, that is used by happy few people all over the world. And we got a lot of measurement with telemetry and other sensors that we put in place, leveraging on the IoT solution. In parallel, we did a virtual simulation of the same car in order to set up a model that should be calibrated and tuned with the data coming from the physical test. And why we would like to do that? Because we would like to make a new virtual model that is replicating the physical one, so that This will enable the designer to make an analysis just using the virtual. This is the process. So we started with our prototype. The prototype went on circuit. We did the tests. We did data acquisition so that the analyst of the test data was enabled to make his analysis. So he was able to search for the car that did the test, select, looking at which was the sensor adopted, selecting the test done, analyzing the test done with the IoT solution, showing, for example, in this case, the engine torque and engine round per minute. Then all those data, once the analysis of those test data is completed, it can share this information with the person that is in charge of the virtual model. So this guy will take in charge the preparation of the data for the simulation. That means that you have to have the CAD model, you have to have the mesh model, etc., as it is shown in this video. You can see that we started from the design of the car and the representation, the meshing, so that we can do the calculation of the eigenvalue and of the vibration mode by applying what? All the information coming from the physical test that was grabbed by the IoT platform. At the end, we can have a model that is calibrated with modification in order to have the same result on the virtual as well we are having in the physical. So as long as we have this one, we can iterate just on the virtual to make improvement. Once the improvement reaches the target value, we can take this information for the development of a new car or improve the prototype we are managing. Finally, what is the target is to have a seamless and integrated environment where I can leverage on the physical data from the prototype and continuously using this data for the product development. Since the beginning, relating the requirements, the initial requirements, to the final results in terms of performance measured on the prototype. Other business case is the one of Meyer Turku. Meyer Turku is a shipbuild company. One of the big issues they have is to be able to make the information during the product development available all the time during the process development. Even information that usually are coming from at the end, having them available at the beginning. What does mean this? Means that, for example, if you would like to know if the new architect solution is the right one, you cannot wait to have the ship built, but you can have the possibility to show before, afterwards, the solution, and then getting the feedback. And that is why we implement, in this case, the virtual reality to make all such representation available in a collaborative environment to a set of people that can bring the information, okay, that is what I'm expecting as passenger. And this is driving the architect of the ship to change and modify as needed in order to get the best result and not to do the rework at the end when maybe the feedback is not the one desired. The last case is, industrial case is the one of Lindbacks. Lindbacks is a company based in Sweden, is producing houses prefabricated in wood, which is the target we adopt in this case, using putting a lot of sensor into the house to monitor the house, to monitor temperature, to monitor water leakage, and to make it available, like with a smartphone, for example, making them available, this information, to everybody, in particular to the tenants, but also to the designer, because the designer, even the measurement of what is happening in the real case in the houses, can change the design so that they improve the behavior of the house itself. And this is clearly producing a lot of the advantages for the Indiebox and for the company. Saying that, so we said we start from the manufacturing changes into all over the world. We saw the industrial cases that we adopt to qualify the platform. Now, I will just show you which are the components of this platform. So there is the Dessault Systèmes solution, that is the 3D experience, providing CAD, providing PLM, providing manufacturing tools to make the simulation too. There is the Alonix company that is providing the iLike platform, that is the one that is able to manage the IoT part of the platform. There is the software provided by Subsea about the environment impact calculation. And then there is the LCPA, that is the software provided by Balance for the life cycle costing. All those are integrated in the platform so that everyone that is working in this environment can start from an entry point, and then when he's entering that entry point, he can get all the information without going outside, exchanging file, and without problem of alignment of information. That is clearly providing a huge tool to be quicker and to be, from the point of view of the quality, better than before. Those are the websites that, this is the website of Manutelligence, where you can find other information. There is also a LinkedIn group, as well as a Twitter one, where we are publishing usually a lot of information about the evolution of the project. We are near to the end of this project, so we are quite near to complete our implementation. And what you saw in practice is the overall coverage of our solution. There will be nothing more in the next 2-3 months that we have still in front. So that's all, Stefan, from my presentation.
We have a few minutes. If anybody, you know what's great about the smartphones now, so that you remember later, you take a picture of it. That way you don't have to worry about what did he say, what was that about, which also has reduced the amount of questions, but we have a wonderful opportunity. It's a wonderful cloud-based opportunity to do work. Do any of you have any questions that you would like to ask Maurizio? If not, Maurizio, I would like to give you this gift from In3Dsty for your taking a great big time out of your day. It's really cool looking when you see that. Yeah.
Very nice.
And thank you very much.
Thank
Another
you.
wonderful expert in the field of advanced additive manufacturing. Thank you very much, Maurizio.
Bye-bye.
Okay. We have